Let us prove that the function fx equal to 3 plus 5x is increasing for all real number x. We'll do it by two different methods. First method, let x1 comma x2 be any two real numbers. It must happen that either x1 is equal to x2 or x1 is less than x2 or x1 is greater than or equal to x2. We can simply interchange and we assume that x1 is less than or equal to x2. Then f of x1 equal to 3 plus 5 times x1. We simply replace x by x1. F of x2 equal to 3 plus 5 times x2. Now, what do you mean by monotonically increasing or increasing? We mean that if we choose higher x2, f of that should also be higher. Since x2 is greater than or equal to x1, 5 times x2 must be greater than or equal to 5 times x1. Okay, and then we can add 3 as well. We add 3 to say that 3 plus 5 times x1 is less than or equal to 3 plus 5 times x2. So clearly f of x1 is less than or equal to f of x2. So if I take higher value of x, then f of that will also be bigger. If I take bigger value of x, then f of that will also be bigger. That's what increasing means. How can we prove it without using this? Or we can do it using calculus. Let's prove it using calculus. You see that fx equal to 3 plus 5x. So f dash x, that's nothing but d dx of fx, which is equal to derivative of 3 plus 5x, and derivative of 3 is 0, 5 is just a constant, and derivative of x with respect to x is 1, which is positive 5. And we know that if the derivative is positive, then the function is monotonically increasing. This implies f is monotonically increasing.